Hello friends, I am Kanchan Vaidya from TSSM's Bivrabai Sawant College of Engineering and Research, Nare. I am from Electronics and Telecommunication Department. Today we are going to perform the practical of radiation and microwave techniques. The title of this experiment is Design, Simulate and Compare the Performances of Microwave Dipole Antenna of length 2 lambda, lambda, lambda by 2 and lambda by 4. So from this practical, we are going to observe the radiation pattern difference for different lengths. And by performing this practical, you will be able to understand the difference between the radiation patterns for different lengths. Now, what will be the difference? The difference is when the length of the antenna is greater than or equal to 2 lambda. In that case, side lobes will be added in the radiation pattern, or for less than 2 lambda, like for lambda, lambda by 2, lambda by 4, and so on, like lambda by 6 or 8, for all these lengths, you will get only the main lobes. That difference you have to study in this practical. So first we will design the antenna. For designing, first we have to consider a frequency. Most of the time in the given statement, the frequency is given. Here we have considered the frequency as 300 megahertz. So first calculate the wavelength from the given frequency. Lambda is equals to C by F. The value of C is 3 into 10 raised to power 8 upon the considered frequency 300 megahertz. So we get lambda is equals to 1. The value of lambda is 1. Now let's design it for the first length, that is 2 lambda. So for 2 lambda, length is, the formula for calculating the length is lambda by 2. We are calculating for 2 lambda, so put that value 2 lambda by 2, 2 gets cancelled and we get the value as 1. Now the length of the antenna is 1. Now we have to calculate its coordinates. So whenever we design any antenna, we have to put it either of the x, y, z coordinate system. Now while putting it on any of these axes, we have to take the total length from the middle at 0. So one coordinate is in the positive axis and one coordinate is on the negative side of the axis. So here I have divided that 1 by 2. So plus 0.5 and minus 0.5. These are the coordinates. While designing it with EZNEC, we'll see how to plot these points in the wire. Now here we have designed it for antenna for the length lambda. So as per the length, lambda by 2 is 0.5. Again, coordinates, as I said, we have to divide it. So 0.5 is divided into plus 0.25 and minus 0.25. Same we have done for lambda by 2 and lambda by 4, and we have find out the length and its coordinates, as you can see on the screen. Now before moving ahead for its radiation drawing on the EZNEC software, first I'll tell you what is a radiation or radiation pattern. See, radiations are what? It is the term which is used to represent the emission or the reception of the wavefront at the antenna and specifying its strength. So to sketch down to represent the radiation of an antenna as its radiation pattern, one can simply understand the function and directivity of the antenna by having its or having a look on its radiation pattern. So the graphically radiation can be plotted as a function of angular position and the radial distance from the antenna. And if mathematically we'll say mathematical function of the radiation properties of the antenna represented as a function of spherical coordinates like E of theta phi and H of theta phi. So radiation pattern is the energy which is radiated by an antenna and it is represented by the radiation pattern of the antenna. So now let's move ahead for the designing of it on the software. Here we have opened the EZNEC 6.0 version. Now see, here when you open the window, initially you will get this screen. Now here by default, the name is last.ez, frequency is given, its wavelength is calculated. As now just in the PPT we have seen, once we consider the frequency, we have to calculate the lambda by C by F. Here by default it considers 300 megahertz and they calculate its wavelength 0.999. It is approximately equals to 1. Now see, here we can change the name of the file. Go to save as. I'm giving name ezprac pr. Save. Yes. Now see, the name is changed. Now, while designing any antenna, first we have to take a wire. See why we are considering wire? Because whenever we go design an antenna, it is nothing but a wire. Designing an antenna is nothing but a wire. That wire consists of number of infinite decimal points. So see, for 2 lambda, first we will design. For 2 lambda, we have the coordinates +1 and -1. So here it is +1, -1 and +1. See, now here I have taken 11 segments. Now for this trial version, we can take segments up to 20. The meaning of these segments is we can divide that wire into number of infinitesimal points. So here I have taken an odd number and it is always preferable because we have to give source at the middle of the wire. So if I take 11, I can skip first 5 and last 5. So 10 are kept aside and at the middle of it we can give the source, the ignition point. That is why I have taken the 11 segments. Now next is source. As I said, we have to give source at the middle of it. Now see, here we have given the specification points. See the segment at which I have to give the source is the sixth node or the sixth segment. First 5 are left aside, last 5 are kept aside, and only at the middle of it, at the sixth point, we have given the source. Now while giving the source, here the type is given. You can select the type like current, voltage, and so we want it in the current form, so I is selected. Loads, transmission line, transformers, L networks, that no need to change. Ground type. Now ground type, the means the material which we use at the ground portion, that can be a free space, perfect, or the real. Here I have selected free space. Wire loss is 0 units in meter. Now plot type, in which plot type you want. First we'll see in the azimuth, then I will show you how it looks in the other forms like 3-dimensional. Will give you the exact view how the antenna looks like. Okay. Now see, here at view ant we can see, as I said, see this is a wire placed on the x, y, z coordinates. See how these green dots will give you an idea. 1, 2, 3, 4, 5. At the sixth one, we have given a source 7, 8, 9, 10, 11. These are the 11 nodes or the segments which we have selected. This is the point where you can see the wire. Now see the FF plot. We have designed it for 2 lambda where the length of the lambda is greater than or equal to 2. That is why here we get the side lobes added into it. So all of you, whenever we are going to designing any antenna for a length, you have to take these screenshots and you have to do it by yourself actually by looking at this video, perform it by yourself. You can download that EZNEC 6.0 trial version and you have to connect, you have to attach these printouts with the write-ups. So this is for 2 lambda. Now see, as I said, here I will show you a plot type of 3-dimensional plot. See how it looks. This is how we get it for 2 lambda with a side lobe. This is a pattern. Now let's design for the other length. Now for the next length, we just have to go to the wire. Remainings are same. Now for lambda it is minus 0.5 to plus 0.5. Remaining things are same. Here in the plot type, we'll first select azimuth, so you will get the exact difference. See, in the earlier one we had the side lobes. Now here side lobes are removed. Only the main lobe is shown. Why? Because the length is less than 2 lambda. Now let's design for the next length. Again go to the wire. Now let's change it by minus 0.25 and plus 0.25. See, again the lobe. See, the widening of the lobe is there. That is the difference. But there will be no side lobes added because the length is small. Minus 0.125 plus 0.125. See the FF plot. So this is how we can design it for lambda by 2. Here we have designed for lambda by 2, lambda by 4. Now and so on, even though you can design it for lambda by 8, the only change is compared to 2 lambda, side lobes are removed. So here we have observed the radiation pattern for all the lengths from 2 lambda to lambda by 4. In this case, we can conclude with this performance of this practical that whenever we have a length is equal to or greater than 2 lambda, we'll get side lobes. Otherwise, in all the below 2 lambda wavelengths, all the remaining in the all remaining radiation patterns, side lobes are eliminated. So this is how you can perform the practical with the help of EZNEC. Thank you.